Alright, hello everyone. I'm going to do a quick tutorial, an introduction to Netfabb. So Netfabb is a software for verifying the integrity of 3D meshes for additive manufacturing generally, so for 3D printing and some CNC processes. So this is very much a technical piece of software. It's not really a creative tool. It's more there for analysis and diagnosis of errors in the mesh and preparation of a component for 3D printing. So the first thing you're going to want to do is add a part. So we can click add part, and then I should have a desktop folder with a couple of files in. Yeah, cool. So let's try this one here. Okay, so when you import your parts, you get a list and an analysis of the file itself. You can see here there's a few options. I would just leave it and we'll run through the repair processes on another mesh. But if you've got a green tick here, generally things are fine. So generally your mesh integrity is going to be fine. Like all your surfaces are facing the correct way, etc. One thing to be aware of though is as we're coming from Blender, your scale is probably going to be tiny. 2 millimeters by 2 millimeters by 2 millimeters. That's not ideal. So what we can do is we can either go back into Blender and scale our object up by 1,000. So that will get us into the correct Blender scale, or we can do that in Netfabb. So the reason you'd want to do it in Blender is if you're working to a particular scale in Blender. I wouldn't necessarily recommend doing it in Netfabb, but you can, if you do, you know that you can export that STL file again from Netfabb, and that's going to be the correct size for developing your secondary component, because that's going to be the exact size you send it away to get printed at. So let's have a look at doing some basic stuff there. So we've imported our object here. As you can see, it's really small, so we're going to need to scale it up. If you have a look along the top here, you'll find there's a scale tool. So let's click on that, and that will take us into the scale tool for this object. Now, we're going to want to scale this up to either by a factor of 1,000 to get to the actual scale we've been working at in Blender, or you can scale to a target size. So we know we have a target volume of 100 by 100 millimeters cubed. So if you use this fixed scaling ratio setting, you can go into here and enter a target size of 100 millimeters, and when you hit apply, it should apply that new target scale. So that should be, if we select this, that should be on its longest. If we have a look at the size here, so it's done this weird thing where it's made that huge, but you just have to hit reset on the calculator here, and it will just clear these values out again. But you can see there that this has, if you have a look in the selected part section here, under size, we now have 100 by 100 millimeter on our X and Y axes, and then our Z axis is a little bit shorter. So we have that. Now, that's all well and good if that's a good part. If that's all, if there's no repairing that needs to happen here, then that's ready to go. So we can grab our object here, our part here, right click, and then export the part as an STL. So really we've changed nothing except for the scale, but we want to export that scale, so we need to re-export the part. You can run repair on meshes like this, but to be honest, it's probably not worth it because you're just taking time where it's clearly just a mesh without issues. Netfabb hasn't identified any issues with that mesh. So let's just go through that process. Export as STL. It's going to run a file check, make sure, tell you that everything's okay, and then we can just drop that STL file into a new folder or wherever we need to drop it. So let's call it project 2 checked or repaired or something like that, so we know it's the one. Okay, so let's maybe get rid of this file, and we'll try something that maybe has some issues. So if I go to add part, and then I choose project 2 test 2, hopefully this one is, yeah, cool. So we've got some warnings here. Still got the same issue with scale, so let's add that part in and we'll see what our issue is. Yeah, see. So here we have some errors in that we have some reversed normals. Now you'll notice that the reverse normals actually affects the, if you export it out of Blender with these reverse normals, it actually affects the geometry. It's not just that the surfaces are facing backwards. The geometry itself actually bends backwards instead of creating these nice smooth edges. It kind of cups into itself. So really with something like this, you actually need to go back into Blender and correct your normal directions here. But I did want to just use this object to show you how to run repairs. So first things first, let's scale it up. So we'll go to 100 again, fix scaling ratio, and hit apply, and then reset to just reset all this back to default. Check our size, that's all well and good, and then we can go and, in fact, there's probably a button for placing this perfectly on the grid, but I'm just going to go move it into place here because it doesn't really matter for us. We're just using the software as a check. Cool, so if we select our object and then we go to the run repair part, you can access all of these by right-clicking on the object as well and going to prepare, repair part, or analyze, compare. You can do a lot of really interesting stuff in the software. So don't count it out entirely just for like the preprint checks. You can actually do some pretty detailed analysis on the quality of the part as well. But let's run a repair check for now. So if I select this object, it's going to tell me that the mesh is closed, which is good. You don't want to have an open mesh. And that the mesh is oriented. I don't know what that exactly means, but it will tell us somewhere that we have some issues with our surface faces in the direction they're facing. In fact, you can see that on the mesh itself, those areas are red, indicating that we have some issues. So how do we repair this part? Well, we can go into actions and we can check in here. So we've got flipped triangles here, inverted orientation. So 30,000 of our triangles are flipped. If we just click on fix flipped triangles, we will now flip all those triangles, but again, you're going to get the same mesh errors. And in fact, not cleaning this up in Blender has meant that now we have self-intersecting faces. So this is now a problem. So this becomes an issue because we haven't designed the model properly. We haven't checked the model properly at each stage. So hopefully that's getting through. Like, you can only do so much with the software with a bad mesh, basically. But we can try and brute force a fix. If we go into this repair scripts section here, we can just execute all of the repair scripts and hope that fixes our issues. If we now go back to actions or status, we can kind of check to see if we have any issues here. And this is probably the more important one, but I'll give you an example of what we can see here in this shells view with a different example file. In view, really, this is just kind of stuff for diagnosing issues, so you might find turning these on or off helpful. But once we've finished that repair script, we can just go apply repair. Now it's going to ask you if I want to remove the old part, keep the old part, or keep and compare. I just go keep the old part. And then we have 2 copies here, and we know that this repaired one, because it's got repaired in the in brackets here, this is going to be our mesh for export. Cool. Okay, so hopefully that's showing you a little bit about how to use the repair script. I know that that wasn't a particularly good example of repairing something, but generally the repair scripts work pretty well. You just have to drop in your file, run the repair scripts, and if you've got any issues at that point, post repair script. If there's still a whole bunch of issues with self-intersecting geometry and things like that, you really need to go back to Blender, back to whatever you're using. It doesn't have, it's not always going to be Blender, but whatever system, whatever tool you're using, and resolve the issues in the design part of the project, rather than trying to fix these things directly before manufacturing. Okay, so the final example I wanted to give you was kindly provided by a student. Thank you. We are going to run a few checks on this particular model, because you'll see here immediately 72 shells. We have lots of different objects and lots of different bodies, and it can be really difficult to combine them and fuse them all together in something like Blender, where the Boolean operations happen on like an object level. Thankfully, Netfabb can combine all of these together, ready for 3D printing, delete all of the unnecessary geometry, and it can do it very quickly and very easily. So if you have an object that you've tessellated with tissue, and you've got lots and lots of different components, lots and lots of different parts, and they don't want a Boolean together, use this process here. Cool. So we'll add the parts, and you can see, again, very, very small, but we have this kind of series of objects here that if we were to go in and try and select all of the different shells, we would find there are kind of 72 different separate objects here, and they all have these kind of overlaps. They're all overlapping, but they're not actually combined together as a single shell or a single body, kind of using those 2 terms interchangeably. So what we want to do first is we want to scale our object up. So again, let's go and target. Actually, let's choose the longest. Sorry, it's not going to let me reset that. So it's not going to. So you want to choose the longest axis, because you want 100 millimeters to be the longest axis. This is, of course, if you haven't rescaled things or worked to scale in Blender first. Cool. So we've got our object at scale. We can pull that in here, and we can try and combine all of these bodies together. So we've got 72 shells here, 72 different bodies, and we need to combine them together. Thankfully, we can just hit this Boolean tool here, and this will do the whole lot. This will do all of the shells, all of the bodies. So if we go in and select project 2 test as our part, and then we go down to these actions down the bottom, if we go unify green parts, it's going to bool all of those objects together into a single object. So this may take longer or shorter depending on your computer, but usually Netfabb is pretty has these kind of processes nailed. So let's go and hit OK. And then we see here in our object here, we've got self-intersections removed. So we've removed all of the self-intersecting geometry and combined all of these objects or all of these shells into a single shell. How can we check that? Let's bring up the repair part dialog and just have a look through the status. And we can see here that we have 1 shell. Before that, we would have had 72. But yeah, maybe just to like wrap things up, we can run another repair. So anytime you click this repair script, apply repair down the bottom, it's going to apply this kind of default repair, or run the repair. If you hit execute or run repair script, it'll do the same thing. apply repair will just apply any of these changes you've made in the repair program. So we can go here, hit execute to run that repair script, and then we can hit apply repair, keep old part, and then we know this is our first part and this is our second part, and this one is ready for 3D printing. So we can right click, export part as STL, and we can select a new folder. Maybe we call it ready to print or repaired, or whatever you call it. Cool. Okay, so hopefully that is a really basic introduction to how to run some repair processes in Netfabb. Hopefully that last example is probably the most general, in that you'll probably have a couple of different bodies trying to combine together, or you'll have some degenerate faces, one or two here and there, that you need to run a repair script on. The presets are fantastic, so just run those preset scripts, and yeah, you'll be able to clean up a lot of different kinds of files, a lot of different files with a lot of different issues, and get them ready for 3D printing. It's a pretty invaluable tool when it comes to working with people who may send you files that you don't necessarily have much say over the design process, but you have to maybe fix them, or you have to incorporate some other element with them, and you need to process those files. So Netfabb's really helpful for that.